good evening to Research Foundation of India, our esteemed expert Dr. Kunal Soni sir, and dearest participants. A warm welcome to all of you with a special welcome to the distinguished Dr. Kunal sir, who joins us once again today on this prestigious platform of Research Foundation of India. Today marks day 6 of 10 days faculty development training program on advanced tools and techniques for research methodology. And as you all know, sir has previously enlightened us with his valuable session on research paper and report writing, as well as understanding impact factor and publication facets. So, and today he's going to take session on hypothesis development and testing. So, without taking much time, I request Dr. Kunal sir to please begin his presentation.
Thank you, madam. Thank you. Yeah. Just confirm the screen sharing. Yeah, I hope it is visible.
Yes, sir.
Okay. So good evening all. So the topic for today's discussion is hypothesis testing and design, right? So we have to understand over here what is hypothesis and testing, right? So basically it is a core part of research, you know. So if somebody is asking you, when you are proceeding for your research journey, if somebody is asking you why you are taking hypothesis, why we need to design hypothesis, and most importantly, why we need to test the hypothesis, right? So there are so many reasons, there are so many aspects, right, that we have to answer as a part of hypothesis testing. So again, today my questions also for all of you, why we need to design hypothesis and why we need to require to test the hypothesis. Yeah, any guesses from the participants? Why we need to test the hypothesis? For which study we are taking hypothesis? Yeah, if you can unmute yourself, so that would be better. I cannot see the chat box.
Sir, I think, as per my opinion, that to check the objective of the study, that is to check the aims of the objective through the hypothesis, that the overall objective and aims are achieving that particular question answer. That is thing.
Perfect. So that is the aim of creating a hypothesis. But now the question is, for which study we need to create the hypothesis? It is obviously correct that for test the objective we have to create the hypothesis, right? But when we are talking about this hypothesis, so which sort of objectives that we are talking about, which part of things that we are talking about, and for which we are designing hypothesis?
To check the relation or the correlation of that particular variables.
Okay, that is again one of the objective for which we are creating hypothesis, and for which we are approving and we are confirming. But the crux of the today's session is the hypothesis testing and design. So basically you are creating hypothesis for the sample study. I hope it is clear.
Yes, sir, got it.
Right, we are creating hypothesis for the sample study. So for population study, we don't create hypothesis. Means, let's say if I'm creating one particular survey in Gujarat state, right, and if I'm considering myself for collecting each and every respondent of Gujarat state, so I'm nowhere leaving the space, right? Nowhere I'm leaving the space where I have to make any assumption, if at all I'm covering the entire population. I hope it is clear, right? If I'm covering the entire population for my study, I don't have to make any inferences. I don't have to make any assumptions, right? Because why we are checking the hypothesis, and based on hypothesis, there is one p-value that we always talks about, if you remember. There is certain value, for which hypothesis acceptance and rejections we are deciding. What is that value? P-value? Yes or no? So what is this p-value? It is probability value. Yes or no? So probability means what? It may be, it may not be. So when we have to make this kind of assumption that, whatever results that we have received out of this study, this may be the answer of all of them, or this may not be the answer of all of them. That means whatever survey that we have taken up, or with this survey, we have not taken up entire population, but we have taken up the part of the population which is called sample. So whatever responses that we have collected for checking those results, it is basically for the samples. And whatever the results that we are receiving based on this collection of the samples, we are assuming that whatever the results of samples are there, that could be the results of the population. And that's why we are taking hypothesis for all the sample study that we are taking. And based on this hypothesis testing and designing and proving whatever results that we are receiving based on the sample study, we are making inferences, we are making assumptions that whatever the results that we have received for the sample study, that could be the opinion of the population as well. I hope the meaning of this particular session is clear to all of you. Is it fine?
Yes, sir.
Okay. So, right. Now, hypothesis is a very scientific process. When we are taking the hypothesis and testing, it is very scientific process. Right. I can say this, that hypothesis is a midway process for the research. Right. So if at all you are doing any research, there is a certain process which is called before hypothesis process. And there are certain process which is called after hypothesis process. So can anybody first tell me what is before hypothesis process? Means when you reach at the designing of the hypothesis testing for any research, which process you are doing before that?
Pilot study.
That is also for the hypothesis testing, so that is correct. But hypothesis testing, I think before pilot study, I don't think so. Pilot study, again, your hypothesis has been done, and based on that, how the data behavior are there. So it is after, I think. What is the before study? Before hypothesis, what you are doing? That means
Framing
you-
questions.
Study of the problems.
Can I say objective if that somebody has already answered in my question earlier? Based on objective, we have to design hypothesis. Yes or no?
Yes, sir.
Right. Whatever your objective for the studies that you are designing, right? So based on this objective, you might be deciding your hypothesis. So objective has direct relation with hypothesis. Ultimately, from the objective, all the hypothesis statements are coming out, right? That could be the main hypothesis, or that could be the sub hypothesis. But it is aligned and it is related with the objectives. Right. Before objective, what you are doing?
Sir, first of all, we have to find the research gap.
Yeah, that's what we will gradually reach to title also. Yeah, so that is what I'm taking up, no? Before process. So there are so many other before processes still left.
Literature review, reviewing all the different types of literatures and finding out
That
different.
is first is gap. And this gap, you are getting it from where? Again, the madam who has answered right now. Literature review.
Yes, from
Yes or no?
yes.
Systematic literature review. Clear? So systematic literature review you are doing from what? Based on title for which you are doing the study. Yes or no? So now if you come to this side, can you relate this process? This is how you are proceeding for the research. First, you will decide your target, the title, right? On which topic you want to do your research. Obviously, it has to be, because without that, your efforts are directionless, right? So based on title, you will have certain variables in your hands, which variables are you going to focus, on all these aspects. So based on that, you have certain literature reviews. So that literature review, you will do it by your own hand. So once literature review has been done, and out of that, you will have certain idea that what has already been done in the past on this particular topic, and what else you can contribute to the society as a part of research. So that is going to be decided. Yes or no? So, right. So this is based on what your gap has been decided, and gap is ultimately the crux and the base for carrying out this research. And so this base has been diverted into a multiple objective that you want to try ultimately. So ultimately, this objective is ultimately for achieving the titles. Yes or no? Your objective should always have alignment with the titles. Yes or no? So and that's why this research is considered to be the complete synchronization process. At no stage you can make your efforts to be on lenient mode. Right? If at all you are making any mistakes at any step or anywhere, if you are deviating from your topic, so ultimately you will make injustice to your research, and sometimes your research will be non-qualitative, qualitative, and through which you will lost the opportunity to publish your paper into good quality journals. And that's where your paper will be black off in terms of creating the impact in the minds of readers, right? So that is very, very important that we should have this process in a systematic way. So once your now the before process is over. Now what is the after process? Your title has been done, your systematic literature review has been done. So based on systematic literature review, you have framed the research gap for your research. Based on research gap, you have formulated your objectives. And based on the objective, you have designed your hypothesis testing. And once the hypothesis testing has been done, what is the next process that we have to do? Yeah, any guesses? Please be interactive. It is, it's not like that I will speak and you will listen. Right. We will have a discussion on this.
Interpretation and analyzing.
Before that, you will directly interpret.
Record the
Yes.
data and edit the photo, editing the data and coding the data.
Data collection, right?
Yeah.
The data has been collected. You will start analyzing data. Right. So here data analysis and interpretation, right? So that both are same part. And once your data has been interpreted, what you will do?
Conclusion and presentation.
Findings and conclusions, right? So findings and conclusion you have to derive, right? So findings and conclusion that we have to derive. Let's say if there is some deviation in the findings and conclusion based on the title which you have decided. So being a researcher, what you will do? You have either one choice. Either you change your title or either you change your finding and conclusion. What you will do? There would be a situation in your research life where you have to face this kind of scenario. So what you will do? What you will do? You will change your finding conclusion or you will change your title. What
We'll
is the
put it into the future aspects if possible.
But what if there is a deviation in the title and finding conclusion? So ultimately, if you cannot change your finding and conclusion, because finding and conclusion, you can see this now, but that is why research is a synchronized process from here to here. So ultimately, the objective of finding and conclusion is to prove your title. So if it is required, you can have some modification in the title, because ultimately, whatever findings and conclusion that you are deriving over here, it is based on data interpretation. Data interpretation is based on data collection. Data collection is based on hypothesis design and objective. An objective you have derived from the gap. So that means this is the stage where you have no idea. Yes or no? When you were at the stage of deciding your title, you were, blank minded. You were nowhere. But gradually, when you gradually grown up in your research, you have gone through the process and you have submitted the facts, figures, evaluated analysis data. And then if you find that this data is having this amount of analysis, so obviously you cannot change the facts. This is called facts, but you have to change the title according to the facts and figures. So obviously you have to see the title, because ultimately the objective of finding and conclusion is to have the achieving the titles, whatever the titles that we have derived, we have to achieve those titles. I hope it is clear. Completely understood?
Yes, sir.
And that's why the hypothesis is considered to be the midway process of the research journey. I hope it is clear. It is a midway process. Understood? So if you are reaching here, you cannot move out anywhere. You have to reach there here only. Right? And once you reach here, and if there is certain deviation, you have to go back. And if it is required, you should have some modification in the title. And now there is some question, sir. In PhD, we have to first decide the title and then research will happen. Obviously, you are right. That's why it has been said that in PhD, people are not doing research, but the actual research journey is starting after PhD. Yes or no? So any journal where you are publishing your paper, that's where you have to see this. And it is my personal experience that, when I'm targeting some papers, I have to change the title of the paper 7 to 8 times. That is bare minimum experience that I have it. Yeah, so that is what we have to see, this title, findings, and conclusions. Clear? Okay. So that is why it has been said that hypothesis is an assumption about the population. So assumption about the population based on what? Based on the samples that we have taken up. Right. So whatever the results of samples that we have received, based on this result, we also assume that whatever the assumption, perception, belief that we have noted for the sample, the same assumption, belief of the population as well. Right. So that is why it has been said that hypothesis is an assumption about the population based on sample study. And that's why it has been said that it is a characteristics of the population that can be measured in terms of means and variances, right? So it is a characteristics of population that can be measured in terms of means and variances, and it must be identified before analysis, right? So whatever characteristics, variables, whatever you need to identify for your research, it has to be defined, it has to be identified, and it has to be specified before the analysis, because once the analysis has been proceed, you cannot change your data, you cannot change your variable, because you cannot go back to the respondent and again ask for their responses. They will not respond at all, right? They are not at all interested if you are going back, and ultimately it will create a negative impression in the minds of them. And that's why one person has also answered that pilot study. So obviously before finalizing your final data analysis after data collection, you have to stop your data collection at 10% or 15% of the total sample size, and you must have to go for the pilot study and must check the behavior of the data in terms of with the second point of this slide, we have to check the characteristics of the population in terms of means and variances. We are usually checking in terms of reliabilities also, that is called Cron-Batch alpha and SPSS. Right, so that is where we have to see that the reliability has to be proven. Otherwise, the data are considered to be the lowest standard data, right? So that is where we have to see. Testing hypothesis. So it is an assumption about the population parameter, that is population mean. So assumption means we have to assume with sample mean with the population mean. So whatever the result of sample mean we have received, we must have to assume that it could be the results of the population as well. Plus or minus 1 or 2% will be here and there. And that's why after collection of the sample data, the researcher calculate the sample statistics. Right. So first of all, you will collect the data for the sample. That's why I had said in the beginning of my slide that when we talks about hypothesis testing and designing, we are always talking about the sample. We are not talking about the population, because we are dealing with the data of samples. We are not dealing with the data of population. But yes, based on the data population, data sample size, we are making an assumption about the behavior of the sample data would be the same representative of the population data, right? So that is why we have to see the sample statistics in terms of mean, variances, standard deviations. So those are the few characteristics, few assumptions that we have to see. And whatever the analysis that we have received at the end of data collection and after applying the data analysis tools and techniques, we have to make out the certain judgment in terms of how the data have been behaved in terms of specific sample data. And most importantly, we have to make the interpretation in terms of the results that we have decided or received, that either they are meeting the entire population or not. And that's why it has been said in research that your sample size should be sufficient in size. That's why it could be the representative of the population at the end of the data. If your sample size are too slow, then I think you are failed to meet the assumption about the population. And that's why there are certain criteria, there are certain formulas in research to calculate the ideal sample size based on the population that we are targeting for the research. Right. So we also have to meet the assumption of the target sample size, right? So that's why this is the complete synchronization process that we must have to see one by one. And according to that, we have to proceed our research, right? So sample size should be sufficient in terms of judging and in terms of representing the total population. If it is too slow, then I think your research will not have that much impact in terms of creating in the minds of people, right? So that's why we have to take care about the population size, sample size based on the population. What is the basic assumption of testing hypothesis? So first of all, as we have already discussed, that we have to validate the data in terms of the reliability. The data should be reliable, authentic, and it should meet up to the expectations of the people and various scientific and research parameters assumption. And you have to differentiate between the sample means hypothesized values and actual values. Right, and based on this p-value, we have to judge whether the null hypothesis got accepted or rejected. So this is the acceptance and rejection criteria for the null hypothesis. If your probability value is greater than 0.05, we failed to reject the null hypothesis. That means we have to accept the null hypothesis. But in research, we never use the statement like we accept the null hypothesis. If you read good papers, good scientific papers, so these papers are never writing like we accept the null hypothesis, because research is always working to reject the null hypothesis. But rather than saying that we accept the null hypothesis, the research uses scientific language in a same word. In both the way, they are using the rejection. But in this case, they are writing we failed to reject null hypothesis. When if the p-value is greater than 0.05, let's say this p-value is 0.100. 0.100, it is greater than 0.05. Clear? And if the p-value is 0.001, so this is less than. So this is in rejection of null hypothesis. Right. So how to acceptance and rejection. So this is the area of distribution curve. Here the rejection and acceptance of null hypothesis decisions has been taken. Right. So this is null hypothesis and this is center point. Right. This is center point. This is called mu. Right. That is called population mean. So this is this is the area of minus infinity to plus infinity, right? That is minus probability value plus probability value, right? So probability value always between -1 to +1. Yes or no? Agreed? Fine enough? Okay.
Yes, sir.
So if your p-value is here in this dark area, this is called rejection region on both the side, on both the side, this is called rejection region. But this is a rejection region of what? We always talks acceptance and rejection always in the sense of null hypothesis. No research is using any terminology like alternative hypothesis got accepted. All research are using the language in terms of null hypothesis. Can you see this? Even they are using rejected word for both the cases, but for what? Null only. Because if null accepted here, so which is going to be rejected? Alternate. But we don't give any statement in terms of alternate. If null accepted, then there is no reason for making any statement for alternate. But if null rejected in this case, right, here is null is going to be rejected. So which is going to be accepted? Alternate. Right. So if alternate get accepted, the null is going to be rejected. Right. In that case, we have to write the statement of alternate hypothesis only in a case of when the p-value is less than 0.05. That means if it is falling over here. When the p-value is less than 0.05, so this is an area of 0.025 because it is a two-tailed test. So 0.05 divided by 2, right? So if this is 0.025 or less than that, then your null is going to be rejected. Or if it is a single style, then it is 0.05. I hope it is clear. One tail, two tail test. This is two tail curve. Clear? Okay, fine enough. But in both the case, it is going to be rejected. But if your p-value is moving from 0.05 to 0.06, then somehow it is falling in this side. So this is a which area? Acceptance or rejection region? This area is acceptance or rejection region? This is acceptance region.
Acceptance region.
Right, this is acceptance region. And it is acceptance region of which hypothesis? Null or alternate?
Null hypothesis.
Perfect. You always have to say null hypothesis. So here we write, we accept null hypothesis or we fail to reject null hypothesis. Research say we always use the word we fail to reject null hypothesis. And if the null is accepted, do we need to talk about alternate?
No.
Not at all. But here we have to talk about alternate, but after deciding rejection and acceptance of hypothesis as a part of findings and conclusion. But again, even in terms of rejection and rejection of null, we have to use the word rejection of null. And if null is rejected, that's why alternate is getting accepted. Is it clear? Because null rejected. If null accepted, nothing to talk about alternate. Is it fine?
Yes, sir.
Okay. So based on that, this is the this is the parameter which is given to us, right? P-value greater than 0.05, p-value less than 0.05, right? So this is a measurement. This is a parameter that we have to talk about. Yeah. And if the difference is high in terms of mean rank, we conclude that the difference is significant and vice versa, right? If the mean rank is different is so high, so obviously mean rank itself shows that, let's say if I'm making the particular assumption on the scale of 1 to 5, right? So if one particular age group like 0 to 25 is having mean rank of 41 and 26 to 50 mean age group is having the mean rank of 668. So this is called high mean rank, right? So that is called difference of opinion. Like let's say these people have opinion at the rated of 2 or 2.5, but these people have rated for 4.5 mostly. So obviously their thinking is different, because one is strongly disagree, 2 is disagree, 3 is neutral, 4 is agree, 5 is strongly agree. So if somebody is saying that, this is almost nearest to disagree to neutral, and somebody is saying that, agreement, that is from neutral to agree. So obviously there is a difference of opinion. So if this is a case, we always have a situation like this. If there is a difference of opinion, always to remember that your p-value should be less than 0.05. And whatever test, whether you are using z-test, whether you are using t-test, whether you are using f-test, whether you are using chi-square test, if your p-value is less than 0.05, all these test values should be on higher side. Always check the results in data analysis. This would be the situation. So there is an inverse relationship between the test value that you are receiving and the p-value that you are receiving. So if your p-value is less than 0.05, means your alternate is going to be accepted. Your all the test value in terms of z-test, t-test, f-test, and chi-square test would be high. I hope I'm making sense. Is it clear?
Yes, sir.
Okay. Any queries as of now? Any sort of query, anything you want to discuss, please ask. Till now. Okay. So this is one example which is given over here. Let's say I assume that there would be. I hope you all have learned about chi-square test. So under which we are using one word that is called observed frequency, and this is called expected frequency. I hope you have heard this word. There are, let's say, 5 observation. So there is an observed frequency which is called OI minus EI. I hope you have heard about it in statistics.
Yes.
Right. So what is observed and what is expected? What is observed and what is expected?
Observed value is calculated value, sir,
Hmm.
and expected value which we uh, इसमें tabulated value, sir. Expected value or tabulated value.
Tabulated means
Uh, which we assume before testing the hypothesis.
okay, assumed value. Let's say over here you can see this. Over here I have written, I assume that the average marks of this class in accounting is 81. So this is my assumed value. For all this observation, I assume that this average is 81. So I assume that all people are having 81 as an average marks. But do you feel that this is a case? Do all the students are having 81? If the average is 81?
No, sir.
The answer is no. So what could be the value here? It could be 68. It could be 78. It could be 81. It could be 84. It could be 91. Right. So this is called observed and expected. So here we have to take the difference. Observed minus expected. And you are taking square of them. Right. And you are dividing with the sample size. So you are getting chi-square. So if this difference is high, right, obviously your chi-square is going to be high. Yes or no? Agreed or not?
Oh, yes, sir.
Yes, sir.
If this chi-square is high, you do remember that your p-value is going to be less than 0.05. And that's why I had made this statement in the previous slide. If your z-test, t-test, f-test, and chi-square is high, you always have your p-value to be less than 0.05. And that shows acceptance of null hypothesis. And that reflects there is a difference in the observed and expected frequency. There is a difference of opinion. There is an impact. There is a correlation. I hope it is clear. For all the parametric or non-parametric tests that you are going to apply, I hope you will learn in this FTP also. Is it clear? Done?
Yes, sir.
Okay. So this is how it should be. And this is how the null is created. So this is called null hypothesis. Mu is equal to 81 means the population mean is 81 means all the values of accounting mark are equal to 81. That is null hypothesis means there is no difference in the student's mark which is observed by 81 as an average. But here they are saying that the students' marks are not equal to the expected marks of 81. There is a deviation. So if these deviations are high, your chi-square is going to be high and p-value is less than 0.05. And this reflects, if these deviations are high, it reflects there is not equals to 81. And this also indicated by the p-value. Yes or no? Understood? So this is how the statistics is going to be run. The test is going to be run. whatever the software you are using, and when we were in the schools, we were using this kind of, handmade process to calculate this chi-square values and all this aspect. Clear to all of you? Okay. So significance level. So although any significance level is going to be accepted in terms of whenever you are proceeding for your research work, you can either proceed for 1% or 5%. But can anybody tell me what is the significance level actually? Why we are talking about significance level in research?
Sir, I can try. Is it the level of error that is acceptable?
Perfect. Significance level is chances of error, right? Perfect. So are you from which field, madam?
Sir, I'm from management.
Okay, great. I'm also from management. So which significance level we are talking? Are we taking 5% or 1%?
So 5%.
5%, sir.
Perfect. Why we are taking 5%?
Sir, in social study, we assume that there may be 5% error acceptable, but in science, it is 1% acceptable.
Agreed. क्यों ऐसा है?
Because of the social science, the human behavior is not predictable as previously. So there are more chances that behavior of the people are different from region to region, from place to place, from time to time, even that particular things
Perfect.
also.
Perfect. So it's a human science, right? It's a social science where the people behavior, people test, people preference are keep changing depending upon the scenario. Even people saying something else in the morning and in afternoon might be, if some significant factors have been influenced, so their opinion might be changing, right? So in a day-to-day basis, also in your workplace, you are observing this scenario. Yes or no? So human behaviors are keep changing. Technological upgradations are also going on. Governmental policies are also changing. So we cannot say that it is going to be as usual. So it is qualitative analysis basically, although we are converting them into quantitative in numbers by making coding and decoding. But ultimately, it is a human science. No, we are actually taking the qualitative data. We are trying to convert those qualitative data into quantity numbers, but actually it is a quality. No? If I'm saying that, what is your opinion? So you might be rate in terms of Likert scale like 1 to 5. So do you think that you have rated at 4? So it is going to remain at 4, irrespective of the situation? Yes or no? It keeps changing. If new companies are there, new products are coming, new services are going to evolve. So obviously you will not like those services. But what is the scientific equations? Right? In scientific equation, it says that 2H and 1O is equal to H2O. So it is not going to change. And that's why it is based on numbers. It is quantitative analysis, where the chances of error are very rare. And it is also expected to be rare because if for making the pure drinking water, if you have to use 2 hydrogen points and 1 oxygen, so if you are making the mistakes at the non-acceptance level, then this water is not going to convert. So the product is not going to accept it, or other product is not going to build up. So the error protections in this science and technology is very less. Like in medical science also, when we are talking about the drugs manufacturing, so it is related to medicines. So if people are taking the faulty drugs, do you think that it is going to affect the human body in a positive manner? It have a negative impact, or other people will leave this kind of companies who are making the faulty medicines, right? So that kind, the 1% level is also sometimes it is not acceptable, right? But in human science, all levels are acceptable. Yes or no? Agreed.
Yes, sir.
Right. So this is called chances of error. So what is this 95% is called? This is called chances of error. Right. So what is this 95%? It is called significance level. Means 5% is error and significant level means confidence interval. We are confident that 95% of the results predictivity is correct. Yes or no? So when we are saying that 5% and 95% are same, although for application of test is same, but in terms of understanding and clarity of the concept, they are different. 5% is chances of error. So if out of 100%, there are chances of 5%. So 95% you are confident, and that's why it is called confidence level, significance level. Is it clear?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
So different test-wise hypothesis testing, I'll show you. Right, how the different test and hypothesis needs to be said. So this is one normality test. Right. Here the hypothesis has been said that in the world, there are only two hypotheses in which the statement of null hypothesis are positive. I hope it is clear. The one test is normality and another one is what I can say data variances, So data variances, that is called Leavenworth statistics. I'll show you in the next slide also. So there are two type of tests where the null hypothesis remains positive, right? And that's why they are not for the inference statistics. Normality and variances are not called inference statistics. But before applying inference statistics, we have to check the data. We have to validate the data, and for which this two test is going to be applicable. If your data is turned to be normal and if your data is to be variance, then you can go for parametric test. Right. Otherwise, you have to go for non-parametric test. Right. So these tests are not inference statistics. They are data validation. And that's why in this data validation test, the null hypotheses are going to be positive statements. Rest all the inference statistical tests that you are going to apply on the data, the null hypothesis is going to be negative statements. I hope I'm making sense here. Very, very important. Although the
Can you
accepted
please, so can you please repeat?
normality test and variance test checking the validity and quality of the data, right? And that's why the null hypothesis for this kind of data are always having positive statement, affirmative statements. You can see this. There is no words called no, not, but it is reverse. Like alternative hypotheses are negative. Like you can see this. But apart from this normality and variance test, right? All the inference statistics like what I can say ANOVA, t-test, paired sample t-test, one sample t-test. If I go for non-parametric test in terms of what I can say is Mann-Whitney U test, Krustal-Wallis test, Kolmogorov, what is that? Wilcoxon sign rank test, for MANOVA, ANCOVA, correlation, regression, right? All those tests, this is called inference statistics, where you are checking the relation between the variables, right? So in that case, the null is going to be negative statement. You will always find there are no difference. We will come on this slide, right? But in this test, the null is going to be positive. But the acceptance and rejection criteria for null and alternative is not going to be changed. It is like this only. Rather, I can say this is like this. So this is standard, The acceptance and rejection criteria for null hypothesis, whether it is normality test, variance test, or it is inferential statistics, the acceptance and rejection criteria for null hypothesis in statistics in universe is common. I hope it is clear.
Yes, sir.
But null hypothesis in normality and variance, it is positive. For rest all the test, it is negative. And you can see this. This is normality test in SPSS. This is Kolmogorov-Minro test, right? So Kolmogorov-Minro and Shapiro. So these two tests are there. This Shapiro test is applicable when your sample size is too less, up to 50. You can use Shapiro. But if your sample size is going beyond 50 on, right, then you have to refer almost Kolmogorov-Minro. So majority of the analysis, researchers are using Kolmogorov-Minro because nobody is working on 50 sample size. It is quite less, right? So if this is, Kolmogorov-Minro, so this is called significance value. We have already discussed this significance value over here. Yes or no? Significance value. So this is 95% significant. What is the meaning of that? 5% is non-significant. That means chances of error. Clear? So if this is p-value is this one, 0.000, you tell me this p-value is greater than 0.05 or less than 0.05. What is this p-value? 0.000. Now you tell me this is going to be greater than or this is going to be greater than?
0.05 greater.
This is significant level, yes. And this is p-value. So which one is bigger one?
0.05.
Significant value.
0.05. So it is less than or greater than sign. What is the rule for putting this sign? The
P
figure
value
which
less
is
than-
the bigger
P
one
value less-
should
P
have
value less than significant value.
the figure which is bigger one. You have to open this two fan window. You know, so this two window is always going to open in front of those figure which is higher one. Right. Let's say if the p-value is coming like this, and this is 0.05. Now which is higher one?
P value is higher.
0.1 is higher.
So the bigger portion will open on this higher values in front of them. Clear? So this is how the p-value greater than and less than is going to be decided. But now this is the actual scenario for all of us over here. Like if you notice, for all the statement, the p-value is 0.000, which is less than 0.05. So which hypothesis got accepted?
Null hypothesis.
Null hypothesis.
Accepted.
Yes, sir.
Yes, sir.
No, sir, rejected.
Exactly. We reject null hypothesis if your p-value is less than 0.05. Are you getting it? And if p-value is less than 0.05, so alternate is going to be accepted. And what is alternate saying in terms of normality test? Data are normal or data are not normal?
Data not normal.
I
So,
hope it
but
is
we
clear.
accept the null hypothesis if it is p value is less than 0.05, right?
Greater than.
अच्छा. Okay.
इसलिए लिखा जाता है ना मैडम कि p value is greater than 0.05. We failed to reject null hypothesis. Means if we fail to reject means we
We